We're going to go through a few examples of problems related to Newton's laws. So let's look at this one. Got an astronaut. This astronaut is doing repairs to the outside of the space station. He then pushes on the space station. I don't know what happens. So let's think about this. We've got our space station. It's a beautiful space station. Nice little box there. And we've got our astronaut here. And he pushes. Well, you know, out in space, they're all floating around. And the astronaut applies a force to the space station. Now, according to Newton's third law, the space station then applies an equal and opposite force to the astronaut. So, well, what happens? There's now a backward force on the astronaut. So, the astronaut will accelerate backward. And so he winds up pushing off the space station, according to Newton's third law. According to Newton's second law, the mass of the astronaut is going to be less than the mass of the space station, and the forces acting on them are equal and opposite, so the acceleration of the astronaut is going to be bigger than the acceleration of the space station. So both Newton's second and third laws apply to this situation, and the astronaut's probably in trouble. Okay. But now let's say he's holding a toolbox. Our astronaut is holding a toolbox. Well, how does that change the scenario? Well, now he's floating away, but he's got this toolbox. If he takes his toolbox and throws it backward, he applies a backward force to the toolbox, then the toolbox will apply an equal and opposite force to him, and therefore the astronaut could make his way back to the space station. Those are examples of Newton's second and third laws, and how this astronaut could save his life using that toolbox in Newton's third law. There's another classic example that incorporates both of Newton's laws. Let's say you've got a father and his little daughter, and they're, sorry, his hands are facing this way, and they're out ice skating together. Okay, and this little girl wants to be a figure skater. So this is Dad. He has some mass. His mass of the dad, mass of the daughter is D as well. Mass of the girl. And they put their hands together and push off each other. Okay. My question for you, take a minute to think about this before you go on, is which exerts a greater force on the other? On the surface, this seems like an obvious answer. You'd think, hey, the dad is probably stronger, so he's going to exert a greater force, right? Well, remember Newton's third law. Object A exerts a force on object B, then object B exerts an equal and opposite force on A. So even though the dad is stronger, when he pushes on the girl, the reaction force of the girl pushing on him is equal and opposite. So the force the dad exerts on the girl is the same, or the same magnitude, as the force the girl exerts on the dad. And that might be hard to believe, but that's how it is. Which is why, if you've ever played the game where you stand and you have to push on each other's hands and try to kind of knock each other over, like, neither party, even if someone's a lot bigger than another person, they don't necessarily have a huge advantage in that game because they're exerting the same force on themselves. Then my other question is, who would fly backward faster? And this perhaps is the obvious answer, in that it's going to be the girl, because the forces are equal, and since the mass of the girl is less than the mass of her dad, then her acceleration is going to be greater. Those are just a few examples of applications of Newton's laws, but you're going to get many more as we go about doing our assignments. We'll deal with, particularly with Newton's second law. The other two don't have much going on with them quantitatively, but we'll deal more quantitatively with Newton's second law next time.